Hello everyone, welcome to the next lecture on the CSIR NET December 2023 solution. Today I will explain you how you can solve the reanalysis questions from the part B. Myself Dr. Harish, you can follow my YouTube channel where you can find the playlist of the CSIR UGC NET and you can see the various PY questions on the various topic is available here. If you are interested to watch the PY questions on the real analysis related to the part B and the part C of the last 12 years, you can watch this lecture. If you are new to my YouTube video, you can simply scan and join my WhatsApp group as here. So let's start with this question. So what is that? They are talking about the infimum of u. So it's a very simple. Can you solve this equation? Can you factorize this? It is x minus 3, x minus 6 which is less than 0. So that means 3 is less than x is less than 6. Similarly, I can factorize this x minus 3. X minus 4 is less than 0. 3 is less than x is less than 4. So can you combine both the equations? Because this is a comma, that's a and. So that means x is less than or equal to 4. So this is basically my u. Now this is my infimum value. This is my supremum value. Now they are talking about the infimum. So the C is the right answer. If they are talking about the supremum, then you can find the 4 is the correct answer. Look at this another one. Consider the sequence and they are talking about the limb sup are here. So it's a very simple question. You can simply remember my shortcut tricks which is given to you by me in my last lecture. You can see the infimum lecture. Fine. You can watch my this infimum and supremum. It's a fully shortcut tricks and how you can solve the infimum and supremum lectures. Whenever you have the term which is called as minus 1 raised to power n, you can break into the two components. When n is even, when n is odd. When n is even, this number will be 1. So if I take the LCM of this, it will be 5n pi over 6. If I take n is odd, this number will be negative. So minus n pi by 2, n pi over 3. So it is minus n pi over 6. But it's a cosine. Cos negative is always positive. So I can written as here. Fine. Now look at that limit of the an. So an will be my cos and only cos. Fine. It is always lies between minus 1 to 1. So this is my supremum. But he said so this option is cancelled. Fine. Now look at the second one is a of 2n. That is my here even number. Again it is my cos. So it lies between minus 1 to plus 1. But he said plus of half cross. Fine. A of 3n. What is the a of 3n? Like a6, a9 and so on. So if clearly say this number, when you take n is my 6, n is my 9, again it lies between minus 1 to plus 1, but he said 0 is not possible. So that means B is the right answer. Okay, look at this another one. Consider the following series are here. Okay, if you think about like of this manner for the first case, can you written like this? And the series of this is my divergent by the p test. Fine. Then according to you, this is my divergent, but that is a wrong statement. Remember always, whenever you have the an, you can write this is less than of bn, provided this must be convergent series. Is it a convergent series? You write this quantity as less than of something. Is that convergent? No. It means you can never write like here. On the other hand, whenever you want to write greater than sign, then it must be divergent. Fine. So it means you can't conclude by writing of this quantity. So how you can solve this question? Very simple tips. Whenever you have a product term en and bn, this is said to be convergent if you prove that this bn is my bounded, this an is my decreasing and goes to the 0. So clearly say if I look about this term sine n pi over 2. So clearly say this value is my bounded because sine function is always the bounded. This value is goes to the 0 and also it is my decreasing. So that means this series is my convergent by using Dirichlet test. So yes, this is my convergent. So B option cancel, fourth option cancel. Fine. Now look at that. For this second part, if I consider an is log of here, now it is not the product of the quantity. I can take bn is 1 over n square. What is my an over bn? It is n square log of 1 over 1 plus n square. Now take limit as n approaches infinity. So it will be 1 plus n square of n square. Fine. So what is this value? This value will be my e. So log of e is my 1, which is finite number, and this series is my convergent by the p test. So that means this is also convergent, but he said bn is not convergent. C is the right answer of this problem. Okay, look at this another one. F is the function which is given to you, f dash is the derivative, s is given to be here. Which of the following statement are correct? If you look about the function, if you look about the option, they are not talking about anything about the f. Fine. They are not talking about anything about the f dash. Everything is dependent on the s. So it means your target is to find s firstly. Fine. How you can find the s? S is dependent on the c. So basically your target is to find c. Fine. Now how you can find the c? Look at that. C is belongs to the R such that this condition. So I can see f dash minus cf is less than 0. Fine. This is the case of this. Now I can start from here. So this is my f dash x minus cfx is less than 0. What come in your mind when you look about this left hand side? It's a differential equation. Fine. It is just like say y dash minus cy. Fine. If I consider as a 0 for example, then what is that? It's my differential equation. It's a first order differential equation. So what is the first order differential equation? How you can solve that? This is nothing but e raised to power cx is my solution. Fine. Or you can find the integrating factor. This is e raised to power minus c dx. Fine. So once you can find the integrating factor here, so that means I can write this quantity as d by dx of fx e raised to power minus cx. Fine. Because e raised to power minus cx is my integrating factor. So this will be here. What does it conclude? What will happen if the derivative of the function is my less than 0? That means this value will be my decreasing. Is it okay? Fine. It's a decreasing for all x belongs to the R. Now I assume this value say hx. Hx is fx e raised to power minus cx for all x belongs to the R, because it is given for the all R. Fine. Up to here is okay. Now that's over. Now they are talking about the for all R. I assume this function. So whenever x is lies between 0 and 1, that means h of 1 is less than of hx is less than of the h0, because h is my decreasing function. Fine. What is h of 1? So h is my here. Can you find the h of 1? H of 1 is f1 e raised to power minus c. What is the f1? F1 will be 0. What is the h of 0? This is f0 e raised to power minus 0. F of 0 is again 0. So this value will be 0. This value will be 0. So that means h of x is 0 for x belongs to the 0, 1. Fine. And otherwise is also 0. So I can say hx is 0 for all x. Fine. Now what is the hx is 0? That means fx e raised to power minus cx will be 0 for all x in the R. Is it okay? Now e raised to power x, this number will never be 0. That means f of x is my 0 for all x is in my R. So is it correct statement? No, because if you take x is my half, then clearly say f of x is my non-zero. So that means this statement is my wrong statement. How this statement will be wrong? Because of this value. Because I start from this, that means this statement is my wrong statement. That means there does not exist any C which satisfies this property. So what does it means? If there does not exist any C which satisfies this property, so what is the meaning of the C? Is 5. That means S is my empty set. So if S is empty, the first option is correct, second option is wrong. 2 comma infinity is a proper subset of the S, but S is my 5, so there is no proper subset of this. This one is 5 intersection 0 comma 1 is not equal to 5, but it also wrong. So it's a very simple question. It's a combination of the differential equation and the continuity or the differentiability of the function. Okay, look at that. F is a polynomial of degree 3 with the real coefficients. Suppose fx has exactly one real root, that is root is simple. So it means it has only one real root. It may be the positive or it may be the negative. So what does that it means? The two roots are my complex roots. Fine. Then which of the following statement hold for the antiderivative? So if f is a polynomial of degree 3, what is my capital F? This is a polynomial of degree 4. Then how many real roots are there? Real means positive or negative. So it could be either 0, either 1, either 2, 3 or 4. Fine. But it could never be a 1. Why? If capital F has a one real root, that means it has 3 complex root, which is not possible because complex root always occur in the pair. So that means this case is cancelled out. It has exactly one real root, cancel. Similarly, it is not possible as a 3 real root. 3 real root means it has a one complex root, that is not possible. Now exactly 4 it could be possible, 2 possible, 0 possible. Now how you can discard the other ones? Again, a very simple. I can assume any of the real roots. So say x is equal to 1 is my root of this. So what is my f? This is my one real root. 2 roots are my complex. So I can assume this is my here. So if I open this, x cube minus x square plus x minus 1. Can you find the capital F? I can integrate them. This x cube over 3 plus x square over 2 minus x plus constant. I can consider constant is my 1, or you may take as a constant 0. Can you find the number of the positive roots? How you can find the number of the positive roots? You can use as the discard rule of sign. So there is one change in sign, one change in sign, one change in sign. So that means this is at most 3 positive real roots. Can you find the number of the negative roots? How you can find the number of the negative roots? I can find the f of minus x. So it will be x4 over 4, x cube over 3 plus x square over 2 plus x plus 1. So clearly say there is no change in sign. So there is no number of the negative roots. So how many total real roots? That is less than or equal to 3. Fine. The total number of the real roots are less than or equal to 3. But he said 4 real roots. That's my cancel. Fine. Again, 3 roots will not be possible. So that means it must be less than or equal to 2. At most 2 real roots, that's possible. At most 1 real root is not possible. So the right answer is C is my correct answer. Okay. X is the non-empty finite set. Y is a real valued function from X to R. What is the cardinality of this X? Is a finite set. I assume this is n. What is the value of the n? I assume it's a 1. You can choose as a 2, that's on you choice. Then F inverse 0. So this is my X, this is my R. The cardinality is my 1, so I assume this is my X. Cardinality of R, it has many values. So one element is my 0. Fine. And this value is my F. Then your first target is to find the F inverse of 0. So what are the possible cases? The first case is whether if it may be possible that if X will map to this element, because look at that, F is any real mapping function. Fine. You may assume f of x is my x, you may assume f of x is sin x, you may assume 1 by x, and many other things. Fine. It is not given that it is a continuous, differentiable, or any one. You can assume any map. So if this map will map to here, so what is the F inverse? 0. Phi. Fine. Second possible case is if this x will map to say this element, then again the element will be 0. Another possible way is if this element will map to this, then what is the element of this is x. It has the two choices. That means this is my F inverse of this. So y is the collection of this. So what is the cardinality of y? Is a 2. Fine. So that means it is my finite set. Fine. Again you can see from here it is my finite set. So once is a finite set, y is my cancel. Now does it has this much element? What is the cardinality of the x is 1. So it is a 2 raised to power 1. 2 elements. Yes, it's satisfied. So this is the correct option. Now since it's only the part B, only one correct option, but anyhow I will tell you how you can see. There is a map from x to y which is bijective. Fine. How you can prove the bijective? If cardinality of x is cardinality of y. What is the cardinality of x? It's a 1. What is the cardinality of y? 2. They are not equal. It means it is not bijective. If it is not bijective, can you say it's a subjective? Yes, it may be. So if again, what is the meaning of the subjective? It's a not onto. Fine. Or onto. How you can prove it's onto? Cardinality of x must be greater than or equal to cardinality of y. What is the cardinality of x1? Is it greater than or equal to 2? No. So that means the function is not onto. Fine. Also you can see if the function is not onto, it means it is not bijective. So if this option is cancelled, automatically this option cancelled. Right option is B is the correct answer. Okay. F is a differentiable function such that f is a differentiable function. What is the degree of the f? What kind of the function f? Whether it's a trigonometric function, polynomial, it is not given. Such that f and f dash has no common 0. So what is the simplest way you can assume that? I can simply assume my function is here. Fine. Such that what is the derivative of this? 2x minus 1. So clearly say what is the zeros of this f? 0 and 1. What is the zeros of this? There is no common 0. Fine. So this function satisfies my property. Look at that. What is the f of half? Minus 1 over 4, which is non-zero. F has infinitely many zeros, but you can see how many zeros have f. How many zeros have f? It is only 2 0. That means it is my finitely zeros. But he said infinitely many zeros. F never vanish in the closed interval 0, 1. But that's wrong. F of 1 will be 0 and 1 belongs to this. So this option is also cancelled. At most finitely many zeros. Yes, it has finitely many zeros. B is my right answer of this problem. So you can see this is the way you can simply solve this question in a simple manner. You can scan and join my WhatsApp group for more discussion part. We will see the next lecture on the part C of this real analysis question. Till then, you can simply like, share and comment on my video. Best of luck students. Happy learning.